the first problem, we want to begin by entering the initial state matrix and the transition matrix into our TI-84. On the TI-84, we go second matrix. We will choose A for the initial state matrix and edit it. Now this is a 1 by 2 matrix, and we enter our two numbers. Second, quit to exit out of the matrix editor, and that will be saved. We do the same thing, second matrix edit, for the B matrix. This time it'll be 2 by 2 with the numbers that you see in the problem. As the matrices get larger, you'll want to be sure that you have the numbers typed correctly, so pause a moment to check your numbers and see that everything is okay. Second quit, we're back to the home screen. So we have just entered matrix A on our calculator and matrix B on our calculator. To find the first state matrix, S1, we need to do S0 times P, which on our calculator translates into A times B. So on our calculator, we go second matrix number 1 times second matrix number 2 and enter. Now there's our answer. I will jot that down. And in the answer box, I need to enter a matrix. Down at the bottom, there's an icon for entering the matrix. So we will choose that. And again, we have to tell it the size of our matrix, similar to what we did on the calculator. Our matrix has 1 row and 2 columns, and we will enter the 2 numbers that we just found. In the second part, we are filling in the rest of the tree diagram. This is in the lesson video if you need more help with it. This information is just a duplicate of what we have in the transition matrix. In our transition matrix, we are going from A to A, and there's the number that goes with it. So we're going from the initial A to the first A, which is what they're talking about here. And so the 0.9 is what we need to enter. Likewise, looking at the transition matrix, the second question is going from A to B. So we're going from A to B, and there's our number. The third question is going from B to A. On the transition matrix, we're going from B to A. That would be the number. And the final one is going from B to B. Now the question 2 is similar to question 1 in that we're trying to find the first state matrix, S1. However, unlike question 1, we are not given the transition matrix. We're given the transition diagram. So what we need to do is to create the transition matrix. So we've got A's and B's. Here's A, here's B, here's A, here's B. And so let's take these one at a time. This point 3, the little circle with the arrow on it, represents going from A to A. That would be this number. The point 7 is on the arrow that's going from A to B. Here's A to B. The point 9 is on the arrow that's going from B to A. And finally, the point 1 is on the circle arrow that's going from B to B. Let me just point out a little observation about these numbers. Do you notice that these two numbers add up to 1, as do those two? In other words, if yours don't, then something is up somewhere. So, like with the first problem, we're going to enter these S sub 0 and P into our calculator. I will be calling these, like I did in the first problem, by A and B on my calculator. So I'll go ahead and make that note here. I'm going to be using A and B. I'll go ahead and type those without showing you all the details. So now, having typed those two matrices into my calculator, I now do A times B as in problem 1, and there's the answer that I need to put in the answer box. In the first part of question 3, we need to take the description of the transition and complete the transition diagram. So in the beginning, we're going from A to B, and that's a point 3. So here on our diagram is the arrow from A to B. So this will be a point 3. These two numbers have to add up to 1. So if A to B is 0.3, A to A would have to be 0.7. We're told that going from B to A is a 0.2. So here's B to A, 0.2. And again, that means the B to B has to be a 0.8. And now we need to enter that information into the transition matrix. This will be a 2 by 2 matrix. A to A is the 0.7. A is the 0.3. B to A is the 0.2. And B to B is the 0.8. In the first part of problem 4, we're asked to identify the correct transition diagram from the information given. So we will start here at the very beginning and see if we can narrow down our choices. In the beginning, we're going from A to B, and that needs to be a 0.3. So here, on the first choice, is A to B, and it is indeed a 0.3. On the B choice, here is A to B, and it is indeed a 0.3. On the C choice, here is A to B, and it's a 0. We can eliminate that. On the D choice, here is A to B, which is a 1, and we can eliminate that. So we've got it narrowed down to the top 2. Let's go to the next part. The second part says if we go from A to C, that should be a 0.3. So on the first one, A, Here's A to C, and it's not 0.3. On the B choice, just to check, here's A to C, and it is indeed a 0.3. So there is our correct transition diagram. Now we need to change that into the transition matrix. Now, if we have the correct choice for our transition diagram, we should be able to write the transition matrix from that. Our transition matrix is going to be a 3 by 3. We've got from A to A. I'll have to scroll through here and show it to you. And we're going from A to A, which needs to be a 0.4. The second box, A to B, is here, and it needs to be a 0.3. Now, if you just want to fudge a little bit, as we said, the numbers in each row should add up to 1. So if we've got a 0.4 and a 0.3 already, then the last one should be another 0.3. However, I'll go ahead and verify that on the transition diagram. A to C on the transition diagram would be here. A to C. And sure enough, that's a 0.3. So in the next box, we need B to A on the transition diagram that we've already got correct. Here is B to A. That's labeled a 0. B to B is labeled a 1. And B to C is 0. And finally, on our third row, we're going from C to A. Here's the line from C to A. That would be a 0.5. We're going from C to B. Here's that line. That's a 0.3. And then from C to C. So for part 1 of question 5, as with the previous problems, I have entered this as matrix A and this as matrix B on my calculator. Now, P to the 4th power means, on my calculator, I need to do matrix B to the 4th power. So, on my calculator, I go second matrix B exponent 4. And that is what I need to be typing into the answer box. So, on the B part, we're wanting the 4th state matrix, S sub 4. And the formula for S sub 4 is S sub 0 times P to the 4th power. Now, P to the 4th power is what we just did. This is what it looks like on my calculator. I will do a matrix A times a matrix B with an exponent of 4. And then enter that into my answer box. On question 6, we're going to be using A to represent those that are using brand X. And so the A means they are using brand X. The A with the little markup above it means they are not. So we're told in this sentence that 80% of those who were using brand X continue to use brand X. So that would be, here's the one that are using brand X, and they continue to use brand X. So this is our 80%. Which means that the only other number, the 20%, are those that went from using brand X to using something else. Then we're told that of those not using brand X, which would be these, that 20% of those switch to brand X. So that would be here. Which means that 80% continue to use their unknown brand. So now we need to turn that into a transition matrix. This will be a 2x2 where the A to A, as we have in our transition diagram, is a 0.8. The A to not A is the 0.2. The not A to A is the 0.2. And the not A to the not A is 0.8. So the percentage of people using brand X 1 week later, in the instructions we are told that this survey was on a weekly basis. So the things that they're talking about happening are happening each week. So when the question asked for 1 week later, that would be state number 1, which we would get by doing state 0, the initial state, times the transition matrix. Now we have the transition matrix. What we need is the initial state. We're told that in the beginning, 30% of the people were using brand X. So our initial state is going to be, here's the ones that are, here's the ones that are not, and this would be 30%, meaning this has to be 70. So we'll enter those into our calculator and find the first state as we did in previous problems. So the first state then, meaning 1 week later, would be matrix A times matrix B, or 0.38 and 0.62. The percent of people using brand X would be the first number, which would be 38%. After 2 weeks, we would have the initial state times p to the second power. And those that are using brand X would be in the first position of that second state matrix, 42.8%. In the last question, we're going to be using the letter H to represent the homeowners and the letter R to represent the renters. Our transition matrix, we will label HR for the rows, HR for the columns. So here we're going to have the homeowners that remained homeowners. In the sentence, we're told 13.1% of homeowners became renters. That would be this number. If 13.1% became renters, then the rest of them must have remained as homeowners. So 100% minus 13.1% would be 86.9%. Likewise, we're told that 16.8% of renters became homeowners. Now that would be this. Renters became homeowners. So that would be a 0.168, which again means that the next number is going to be 1 minus that, or 0.832. So there is our transition matrix. We're told in the first sentence that in the beginning we had 39.4% that were homeowners. So our initial state was homeowners, renters, 39.4%. And again, by complements, we know that the renters must be 0.606. The tricky part of this problem is in how they describe what's going on. A census is done every 10 years. The original census was in the year 2000. The question we're asked is, what about the year 2010? Since the census is done every 10 years, 2010 would be the first census after 2000. So we're looking for the first state. So S1 would be S0 times P, which I'll do on my calculator. And the only one of the numbers that we're interested in is the one that corresponds with the homeowners, since the question asked what percent were homeowners. And that would be the first number in the matrix, which would be, rounded to the nearest tenth, 44.4%. Now in 2030, that would be the third state after the 2000. So we need to do an S0 times P to the 3. Again, we're interested only in the homeowners, which is the first number of that matrix. To the nearest tenth, that would be 50.4.